Hey everyone, thank you for joining us today. This lesson is specifically for fourth grade students, but anyone can join. My name is Amber Smith, and I'm a fourth grade teacher at Finch Elementary in Spokane Public Schools. And today I'll be your teacher for this lesson. We are going to be talking about fractions, and the concept that we'll be talking about is how do you find equivalent fractions for certain numbers. So get your pencil, paper, and your fabulous brain ready, and we will begin.
All right, let's start with a little warm up today. And we are going to start with adding and subtracting fractions with like denominators. So when we're talking about fractions with like denominators, we're meaning the denominator is the same. So when we're adding fractions or subtracting fractions where the denominator is the same, all that we have to do is add up the numerators. So that's the top number. So a 1 plus a 1. And then the denominator does not change. It's kind of like a label in that we're talking about, for these two fractions, 1/4 plus 1/4 equals 2/4. We're talking about fourths. So it's not changing at all. So let's try that with a couple more. What if we added 1/8 plus 5/8? So first we add the numerators, and then the denominator just stays the same. Let's try that with a subtraction problem. So it works exactly the same way. Our denominator is not going to change, but our numerator will. So 5 take away 2 is 3. So when we add and subtract fractions that have the same denominator, the denominator just stays the same, and we look at the numerators. So that is how you do that. So there's your little mental warm-up. And today we're going to be talking about generating, so making equivalent fractions. And what is an equivalent fraction is really the first thing we need to talk about. Equivalent fractions are two or more different fractions that represent the same quantity or amount. So let's talk about a really quick example that you might be familiar with when we're talking about this. So one example might be is if I had a sandwich, and if I ate half of that sandwich. So this fraction represents 1/2. So this picture model represents 1/2. If I wanted to find an equivalent fraction of this, I'm thinking about what are some other fractions that really mean the same amount, even though the denominator and the numerator might look different. So here's one way you can do this with a picture model, is what if I split this in half again? What is that fraction now? Can you think of what it is? Well, I think about how I have 2 sections shaded in and how there are now 4 sections altogether. So what I'm saying here is that I have 2 different fractions. They look very different. So 1/2 and 2/4 look like different fractions, but they really represent the same amount. We're talking about they are the same amount. They're equal to one another. All right. So let's talk about how do we make equivalent fractions? What are like the tricks to doing that? What's the process? So we're going to start out with the fraction 3/4. And I'm going to show you today how to use a picture model and how to use an expression, so mathematically with numbers. How can I show you how to find equivalent fractions? So our first step that we're going to do today is we're going to show a picture model of 3/4. So I'm just drawing a picture of it. I have 3 out of 4 sections filled in, so this is 3/4. And now I want us to talk about, like we did on the prior page with 1/2 and 2/4, how can we show an equivalent fraction to that? So how can we find another fraction where the numerator and the denominator might look a little different, but they really mean the same thing? So there's a couple little mathematical things you can do with this. One, with the picture model, I draw 3/4 again. is I can talk about how I can split this up. So let's say I wanted to split it up, each of these sections, into 2 equal sections. So you can see that I haven't shaded in anymore or shaded in any less, but I've split it up. So let's talk about what's happening here. So I have shaded in 1, 2, 3, 4, 5, 6. And altogether there are 1, 2, 3, 4, 5, 6, 7, 8. So an equivalent fraction to 3/4 is 6/8. But let's talk about how can we show that with an expression, like with math terms. So there's one thing that we can try here. So I split up each of these into 2. So I can show it like this. Now that's interesting, isn't it? When I add this 2 halves into that expression. So 2 halves. So what do you know about when I write fractions like this? Do you remember anything about those from talking about fractions in your learning this year? Well, I'm hoping that you understand that when you see 1/1 or 2/2, 2 halves, that really they're saying, so there's the 2/2, here's the 1/1. What do you notice about what I'm shading in this time? I'm shading in everything, right? So it means one whole. So basically what I'm doing down here is I'm multiplying by 2/2, but that really is like multiplying by 1. And I'm not changing the value of the fraction. So how this works is I can show a picture model like I did here, and I split everything up into halves, each section into another 2 pieces. But I can show it with mathematics with an equation. So if you look here, I can do, since I split it up into 2 pieces, I have 3 times 2, which equals 6, and I have 4 sections, which I split up into 2, which equals 8. Interesting, right? So there's a picture model I can do, and there is a mathematical way that I can write an expression. So let's try that with another one, still looking at 3/4 as our model. So now I have 3/4. Notice how I'm not changing the value. I still have the same amount in every single one of these. But I'm multiplying it by something just to figure out what's another fraction that would be the same as that, even if I cut it up into smaller pieces. So let's try with cutting it up into 3 more pieces. So my first step is I draw the picture model, and I also write the expression. So when I talk about expression, I mean here. Then let's show with the picture model how we break that up. So if I'm going to talk about breaking it up into 3/3, we're going to have to break up each one of these sections into 3 chunks. Okay. So now I've represented it with a picture, what I'm doing with this expression here. I'm breaking it up into 3 pieces. Now, we have a couple ways we can solve this. One is we could count the pieces and get our fraction, or we can multiply the expression and figure it out that way. Let's do it both ways. So let's count what we've shaded in with these new sections. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you look here, 3 times 3 is 9. So we're matching up, aren't we? And then let's count for our denominator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is 3 times 4. So now what we have found on this page with multiplication and picture models are equivalent fractions to 3/4. So 3/4 is the same as 6/8, and it's also the same as 9/12. These are all equivalent fractions. They're all the same amount. So that's what we're working with here. Let's try it with another one. And if you haven't been drawing on your paper with me, I would like you to do that. And we're going to look at the fraction 4/6 now. So my first step is I'm going to draw a picture model of that. I'm going to shade in 4 of those 6. Okay. And now, because this one is not changing, I'm going to leave this one the way it is. I'm not going to cut it up into smaller pieces. That's why I put the 1 over 1, because 4 times 1 is 4. I haven't made any extra pieces. And 6 times 1 is 6. This one has stayed the same. Let's do it with another one. Now we're going to change the 4 6. We're going to find that equivalent fraction. So I'm going to draw my model. Let's break it up into 2 pieces this time. So I'm going to write my expression. So 2 over 2, which is like a 1, remember? It's like 1 whole. And then now I need to solve it. So with the picture model, I need to cut it up. So if I'm timesing this by 2 over 2, I'm going to break each section of the fraction up into 2 pieces. And then I could count that to solve it. So if I were to count it, I'd have 1, 2, 3, 4, 5, 6, 7, 8, which is like here, 2 times 4 is 8. And then if I counted all the pieces for the denominator, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just like right here, 6 times 2 equals 12. So 4 6 and 8 twelfths are equivalent fractions. All right, let's do it with another one. Let's find another equivalent fraction to this. So I'll draw my 4 6. I'm hoping you're understanding the process a little bit here, that first we draw a picture model, get my 4 6, my original fraction. Then I'm going to write my expression. We're going to break it up into thirds this time. Then I'm going to break it up. So each section, I've got 6 of them that need to be broken up into thirds. Now the bigger number that you multiply this by, the more chunks you have to break these up into, which gets a little challenging. Like if you were going to break it up into 50 or 100, that'd be pretty hard. You might just have to stick with solving the expression. But I think it's important for you to see the picture model with the expression so you understand how it works. All right, so now let's count those up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which should be the same as this, right? 4 times 3 is 12. And then we can count all of these down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 6 times 3 should be 18. So all of these fractions are equivalent. While the denominators and numerators may look very different, they all take up the same amount of space. They're all the same. So that's the process. So step 1, draw your picture. Step 2, write your expression. Step 3, break up the chunks in your picture model and solve your expression with a multiplication. And those are your steps for solving these. Let's do one more together. Let's do 2/5. We're going to do something a little bit different here, because you don't always have to go in order of like 1 over 1, 2 over 2, 3 over 3. You can do it however you want. Let's try this one with 4 over 4, so 4 fourths. So we've got 2/5. We're going to start with our original fraction. And let's multiply it by 4 fourths. So what are we going to have to break this up into? We're going to have to break each section up into 4. So we're getting these skinny little pieces now. Breaking each one up into fourths to show it on my picture model. Just like that. And then I can count 1, 2, 3, 4, 5, 6, 7, 8, which is that 2 times 4. And then I can count for my denominator too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 5 times 4 is 20. So I have 8/20ths is equivalent to 2/5. If I wanted to do a bigger number and I don't want to draw the picture model, I can do that too. Because I think sometimes, like I said previously, if you're trying to do times 50 or times 100, it'd be really hard to show on a picture model. Let's try 2/5. And let's say I wanted to get the denominator into maybe 30ths. What would I have to multiply this by to get it into 30ths? So I'm thinking, okay, 5, 10, 15, 20, 25, 30. Well, that's a 5 times 6. That's 6 times. So I need to do the same on the top. So now all I have to solve is the 2 times 6, and that is 12. So 2/5 is the same as 8/20ths and the same as 12/30ths. Those are all equivalent to each other. So those are the steps for figuring out equivalent fractions. You have a way to do it with a picture model. You have a way to do it with an expression using some multiplication. So remember the steps. For the picture model, you're going to draw the original fraction. You're going to break it up depending on what you want to multiply it by. Then you're going to have to count out in the picture the new numerator and denominator. If you're solving it with the expression, then you take the original fraction, you multiply it by what you, the whole number that you're going to multiply it by, 6/6, 5/5, 3/3, whatever you want to do with that, whatever you need to do with that, and then solve for that multiplication to get your answer. So how can you practice this on your own? Well, you can write any fraction. So an example might be 2/3. You can draw a picture model of that, decide what you want to multiply it by, divide the picture model like we did in our example, so chunking it into those other pieces. But you can do it with absolutely any fraction that you want. And then after you've practiced it, ask your teacher how you can share your work with them and show your learning. I've really enjoyed doing some mathematics with you today, and I thank you for joining me as you're learning from home. And I hope that you have a wonderful rest of your day.